This is Srikanth Tadavati. You watching Srikanth Ideal Chemistry. In this video, we are discussing about stability of carbanions, and this is next application of inductive effect. So the stability of carbanions is quite opposite to stability of carbocations. So here the stability of carbanions is directly proportional to minus I effect and inversely proportional to plus I effect. I mean, for the carbanion, minus I group is present, stability is increased, plus I group is present, stability is decreased. So here also we will explain the stability of carbanion based on the priority order of I effect. What is? Here also we use the priority order. So first we give the high priority for distance, then number of I groups, then power. Okay, so here I just give some examples based on this. First I just give the example based on the power. For power, so here I just give some examples for power. First structure, second structure, third structure, fourth structure, fifth structure, sixth structure, seventh structure, eighth structure, ninth structure. So here we have 9 structures. All these are depends upon power of the minus I power. So if you take the order of their stability, so here all are examples for carbanions. So NO2 is a minus I group, OH also minus I group, CHO minus I group, CN minus I group, alkox is also minus I group, chlorine also minus I group, methyl plus I group, hydrogen reference group, and this also minus I group. So most of the compounds can have minus I groups. So based on the power of minus I groups, why? Because all plus I groups and minus I groups are present in the same position. So here we can explain based on the power. So the stability of carbanions is directly proportional to minus I effect or minus I power. So based on this, which is more minus I power, that is most stable. In that the first structure having NO2 group, so it is NO2 group having maximum minus I power, so it is highly stable. After that cyano group is having maximum minus I power after NO2. So next, fourth one, after aldehyde we get third one. After aldehyde, we need to take the halogens. So in the halogens, we have 2 halogens here, chlorine and bromine. So chlorine having more minus I power than bromine. So next we get the 6th structure after 9th structure. Then after halogens, the next minus I power group is alkoxy. So next structure is OCH3, and next one is OH. Okay, after we need to go for the second structure. This is second, structure 2. Okay, second structure. So after we need to go for the 8th one, reference, and then and last one is 7th one. Why? Because due to plus I group, the plus I group can be decrease the stability of carbanions. So at last we take the 7th one. Okay, this is the order of stability of given compounds. Okay, so we will go for next example. So next example, see carefully. Next example is based on the number of I groups. So for based on number of I groups, here I just give one example. CH3, C, CH3, CH3 minus. This is a structure 1. We call as structure 1. And second one is CH3, CH, H minus. This is the structure 2. And next one CH3, C, CH3, hydrogen. And last one H, CH, H minus. So this is structure 4. So when you observe that in the first structure the carbanion attached to the 3 plus I groups, this is plus I, plus I, plus I, here 1 plus I group, here 2 plus I groups attached to the carbanion, here 3 hydrogens. So the plus I groups can be decrease the stability of carbanions. So then we just take the order of their stability. So based on the stability due to presence of plus I groups, fourth structure having maximum stability, after fourth one, second one, after second one, third one, and first one is at the last. So then order of stability is is equal to, so if you see that if you see the structures, so they are the structures. Fourth one is more stable based on the discussion, after second one is more stable, after third one, and first one is at last. So due to presence of plus I groups, their stability is decreased from fourth structure to second, second to third, and third to 1. Okay, and next we go for the next example based on the distance. So next example based on distance, so I just give an example, so just see carefully. So this is the structure 1, and this is structure 2, and this is structure 3, and this is structure 4. If you take the order of stability, if you see this here the cyano group is example for minus I group. So all structures consist of minus I groups except fourth one, but in the first one the minus I group is very near to the positive negative charge. So you know very well the stability of carbanions is directly proportional to minus I power. So first structure is more stable. After in the second structure we have 2 carbons between minus charge and minus I power, minus I group, but in third structure we have 1 carbon between a minus charge and cyano group. So third structure is the next highest stability, next second structure, and fourth structure at last. Why? Because due to absence of minus I groups. So this is the order of stability of given compounds. And one more example for this category. So just give, this is first one, this is second one, and this is third one, and this is fourth one, and this is fifth one, and this is sixth one, and this is a seventh one. If we take the order of their stability, so in the first structure cyano group is minus I group, NO2 also minus I group, both chlorines are minus I groups, and fluorine also minus I group, bromine also minus I group, chlorine and iodine minus I groups, and methyl is plus I group. So due to presence of plus I group, the plus I group is inversely proportional to stability of carbanion. So it is at last position. Okay, when you see this in the first structure, the minus I group and negative charge are present on besides to each other. In the second structure, we have one carbon difference. In third structure also we have one carbon difference. Fourth structure, fifth structure, and sixth structure we have one carbon difference. So first structure having more stability than remaining one, and next position is here. In the second structure we have only one minus I groups, but in third structure, fourth structure, fifth, sixth structure we have two minus I groups. Here two chlorines are present. Here one chlorine, one fluorine is present. Here chlorine, iodine is present. So based on the minus I power, fluorine having more minus I power than chlorine. So next position is fourth one. After chlorine having more minus I power than iodine. So next position is third one, and next one is sixth one. After we need to compare the second and fifth structure. In NO2 and bromine, NO2 having more minus I power. So next position is second structure, after fifth one, and at last is the seventh one. So this is the order of stability of given carbanions based on the inductive effect. So okay students, this is about stability of carbanions. In the next video we are discussing about stability of free radicals. Okay students, if you like my concept, please subscribe to my channel. Please like and share my videos. Thank you.